just as there are multiple ways to skin a cat, there are also often many ways to approach the same integral. So let's take a look at this particular case. I've got y equals x over 2, and I've got y equals square root of x, and I actually want to find the area between those pieces. And that crosses over at the point where x is 4 and y is 2. So I've got this point, the origin, and this point where it's x is 4, y is 2. So I'm going to set up two different integrals, and I'm going to show you that they're the same result. The first one's going to be fairly straightforward, which you probably expect. The x values are going to go from 0 to 4. The y value is going to go from the bottom function, which is x over 2, to the top function, which is square root of x. Okay, so then we're going to integrate the way we normally expect to. So in that case, we integrate, we get y, we plug in the limits, it gives us that. We keep going, we get two-thirds x to the 3/2 minus 1/4 x squared. So when we plug in the 4, we have 2/3 4 to the 3/2 minus 1/4 4 squared. Now, and then the 0 cases, those drop out. So we get 2/3 times 8 minus 4, 16/3 minus 4, which is 4/3. So the area there is 4/3. And that's the way that we've learned so far. But let's try to look at it a different way. So in this way, what if we say, we look at the y values? What I notice is in the y values, I go from 0 to 2. And in the x direction, what I notice is since the positive direction is this way, I go from the bottom function, which is what we think of as the square root function, all the way, so that we go from the bottom to the top function. So I have that, but I don't want a y as a function of x. I want x as a function of y. So if y is x over 2, that means that x is 2y. And if y is the square root of x, it means that x is y squared. Now the caveat here, this only really makes sense if y is non-negative, is 0 or positive. And in this case it is, so we don't have to worry about that. So instead what I write is I say it goes from y squared to 2y. And instead of dy dx, I get dx dy. So I get x from y squared to 2y, which is the same thing as saying 2y minus y squared dx, which is y squared minus 1/3 y cubed from 0 to 2, which y squared is 4, y cubed is 8. So we get the same answer, but I also want to point out that I personally think this is easier. There's a little more work done on the front end here, but I hate 3/2 powers. I don't like it. I don't like fractional powers. It just annoys me. So by doing this, I can avoid fractional powers and I still have some fractions, but I don't have fractional exponents. which in my life makes it easier. So in some cases, what you're going to find is it makes a lot more sense to integrate it starting with y, and other times it makes more sense to integrate starting with x.